Okay, again, welcome back. We'll continue our discussion on the interfaces. The partial implementation of an interface, I think I've already told you this concept. When you are implementing an interface, and if you know that it is the responsibility of the class to implement all the methods which are declared inside the interface. But in case if class opts for implementing few methods and leaving other methods unimplemented, then obviously that class need to be an abstract class. That class cannot be left as a non-abstract class, but that class need to be abstract class. And you know that abstract class is a class for which you cannot create object, right? So here the example that we have been saying throughout this interface discussion, say for example, if inside Kate I implement sound, but I do not implement food, right? I just use multi-line comment to comment this whole food method. Now you know that Kate is implementing animal. Animal had two methods, one was sound, other was food, right? Kate implements animal, but it gives implementation of sound and does not give implementation of food, right? And it has got its own toString method, and it has got its own method 3, right? Now in this case, when Kate is giving partial implementation of animal, then this is really not an option for the Kate. In this case, Kate has to be abstract, right? Because otherwise it will be an error. You can see here. Now if I compile Kate, javac Kate.java, should be an error. I haven't saved it. Okay, save javac. You can see here Kate is not abstract and does not override abstract method food in animal, right? So you can see compiler is complaining. Compiler is saying that if Kate want to implement animal, then it has to implement all the methods which are coming from animal. But if Kate cannot do it, then Kate must be abstract itself, right? Kate must be abstract itself. So now this should not be an issue. You can see when we declared Kate as an abstract class, then it's okay. It can give partial implementation of animal class. But then you know the problem. Now when we come to our animal demo, here we are trying to create object of Kate, and now Kate is abstract. So obviously you cannot create object of abstract class. You see that it will be problem here. Javac animal demo.java. So this is Kate is abstract, cannot be instantiated. Right, so it's clear that if you want to implement an interface, you have to implement it fully, otherwise you have to be abstract, right? Although Kate has got another option. I mean, maybe we can have another class which derives from Kate, right? So say for example, I have another class here. I say maybe class fully Kate, fully Kate. So this is a class that is extending from Kate, right? Now because this is extending from Kate, then it is the responsibility of fully Kate to implement any methods which is abstract inside Kate. Now obviously inside Kate we have not declared any abstract method, but the problem is Kate is implementing animal, and inside animal we have got an abstract method which is food. It means that this fully Kate, which is extending from Kate, it is its responsibility to give implementation of food. I mean, it can have many other methods, but the implementation of this method is mandatory for this fully Kate class. So maybe I can write here public void, and that is food method, right? Food, right? And then system dot out println Kate drinks milk, right? So you can see here now fully Kate, which extends from Kate, it is giving implementation of food. So I can now compile this Kate cls when I compile kate.java, it will also give me fully kate, fully kate class file is also there, right? Because when I compiled this whole file, it had got two class files, one for kate, other for fully kate. So this fully kate has also been compiled, right? So now an animal, rather than working with kate, I should work with fully kate, because this class is giving you implementation for sound and food. Now this should be okay, right? You can see here. Now if I compile animal demo, that should not be an issue. Reference method, yeah, method 3, it is not known to the animal. So on this reference you cannot call method 3. We have already seen this problem. Okay, you can see now this code has been compiled, right? So you got the idea that when you partially implement an interface, then you can make that class an abstract class, otherwise it won't be compiled. So if you have a class which is implementing an interface, then it is mandatory for the class to give complete implementation of the interface. When I say complete implementation of the interface, I mean that it has to implement all the methods which are coming from that interface. Otherwise, that class itself has to be abstract, and the use of such class will be that it will be acting as a super class for another class, which we saw in this case fully kate, which was driven from the kate class. Okay, great. The next concept in interfaces is the nested interface. An interface can be declared as a member of another class, or it can be nested inside another interface. Let me give you an example. I am going to, by the way, this is the ID for the next Zoom session. You can take a note. I will also be sending you on WhatsApp, as well as text you through LMS. Okay, so let us see an example. I'm going to close this, close this, close this, close this. I'm going to write another example, notepad, where we'll see that how an interface can be declared as a member of a class. So say for example, I've got a class, I call it A, right? And then I have a class, I call it B, and then I have a class, I call it AB demo, right? Now inside class A, I've got an interface. I call that interface as mathematics, right? This interface is going to define an integer sum, integer A, integer B, right? That's it. You know that it's an abstract method. Its name suggests that it will perform addition, and this parameter list shows that it will accept two number, and common sense says it will add those number and return the value, right? Integer, I have maybe a square, right? Integer number, right? So again, it's very common sense that this method it will calculate a square of a number, the one which you pass as an argument to this method, right? So this interface, the important thing is it is declared inside a class, right? Now this class B wants to implement A dot mathematics, right? So you can see here how I'm referring mathematics. Now mathematics is inside A, so I have to prefix it with the class name, right? If I just write A, it will be trouble, because A is mathematics is nowhere. So obviously your compiler will not be able to locate mathematics. So if you want your compiler to locate mathematics, you have to prefix it with the class name. And now you know the responsibility of B. if B is implementing this mathematics interface, then it has to give, you know, implementation of both of these methods. And you know that if it is not giving implementation of these two methods, then B itself need to be abstract. Right, we have already discussed this previously. Okay, so what we are going to do, we are going to, in this class B, which is sum integer A, integer B, right, and this will do nothing, this will just return A plus B, that's it, right. Similarly, we also need to implement square, right, integer number. By the way, you know that these are just identifier and you don't need to follow exact same identifier, that's not requirement. You're a programmer, it's not like ratta thing, okay. So return n into n, we are going to return the square of the number which you are going to receive in this method, right. Okay, so you can see here we have a class, inside that class we have interface, and we are implementing that interface inside class B. And by the way, this class is completely free to create any other method, to define any other methods, I mean, this is an ordinary class, so it can have more member variable, it can have its own more, you know, methods, whatever method it is going to define, that's completely fine, because this class A is still a class, right. So it can have more methods, it can have more member variables, right. I don't want to make it complicated because I just want to focus on this to understand the concept. Okay, now I've got AB demo. Now inside AB demo I need to have public static void main string arg, okay. Right, then what I'm going to do, I say a dot mathematics reference equal to new B. You know this arrangement, right? You have seen this arrangement many times. You've got reference of the interface, and then you've got object of the class which is implementing that interface, right. So now I can call reference dot, you know, sum, and then I pass 90 and 10, you know, it will return the value, and I'm going to print that return value, system dot out dot println this and then this, right. AB demo dot java, right. I can also call the other method reference dot square, and then I pass it a number, it will compute the square and return, right. Okay, so now I say java c ab demo dot java b implements, not implement, it is implements, okay, java c you know the problem, B is not abstract and does not override abstract method square. Well, square, okay, cls java c. Now the method cannot be implemented in mathematics. Square and B cannot implement square and square integer number, you know that these are public methods, so you need to make them, you need to declare them public. We have also seen this issue that less restrictive access modifier cannot be assigned, java c, right. So AB demo has been compiled. Java AB demo. You can see 100 and 100. Right. Sum of 90 and 10. Right. And square of 10. So you saw that inside a class we can have interface, and this is how that interface will be referred to. And then obviously because B is implementing that interface, so it has to give implementation of both of these methods. Right. Okay, that's great. The concept of nested interface has been clear. Now when you come back in the next video, we'll see how to apply interfaces. In that video you won't be seeing any new concept, but you will see how interfaces can be applied in real world. Thank you very much.